saja mesti buat.
Okay.
Okay?
Statworks one Amy.
No.
Partner.
Partner is Amy. Statworks one we all doing.
An analytic solution. So our HQ office is based in Malaysia with branches in Singapore and India. So we provide two kind of services, which are distribution, which we distribute a license for computational analytic solution. And then we also implement services including training and consulting. Okay, next, this is our leading solution partner. So our partner are various from TIBCO, Data Science Platform, Perceptron, IBM, and so on. You can see all our partner over here. And then for the EViews itself, these are the key customer that using EViews. So EViews, the use of EViews are various in the country. You can see different country, different department use for EViews. So you can have a look on the list for the key customer for the EViews. Right, so next, I'm going to introduce to you a little bit on EViews. So as you know, EViews are good in handle econometric data, and then good also in doing forecasting. So EViews actually owned by the IHS Market Limited, and then I believe that almost every year EViews will update their version. So different kind of version. Will have different new features. So right now, the latest version of the EViews are EViews 11, right? So EViews, as you know, EViews is the ideal package for anyone that working with time series, cross-section, panel, or longitudinal data. So by using EViews, you can actually manage your data in which you can performing your data. For example, you want to do graphing or maybe do statistical analytics into your data. So EViews can do the statistical analytic, and then it also can perform econometric and statistical analysis, and then good in generate forecast or model simulation. Other than that, it also can produce high quality graph, which you can see few example of the screenshot of graph that can be produced by EViews. Right. So next, for the interface of the EViews, I believe that EViews are user-friendly interface, which means that if you are familiar with Microsoft Office Outlook, I think you don't have any problem to use EViews, because EViews basically same as Excel, which is in the EViews you can just drag and drop your foreign file into the EViews, and then you can have different sheet in just one file. Okay. And then EViews also easy to use, because when you want to conduct an analysis or doing graphing, you just simply can click on the button and it will produce the output. Okay, next is EViews come with the Windows integration, which is if you have outside data from the EViews, you can actually simply drag and drop your Excel data, for example, into the EViews, and EViews are smart enough to read the data, which means that if you have the data in time series, it can read the data whether the data is in daily or monthly or maybe quarterly data. So it is easier for you just to drag and drop the data into the EViews. Okay. Next, EViews also come with the multiple window display, which means that every time you try to do analysis on your data, for example, if you do graphing and then you do statistical analysis, both will come out with different live window pop-up. So as you can see the screenshot over here, each result come with their own windows. So you can save each result into different kind of file in two different kind of object in the sheet of the EViews. So by having the multiple window display, it is easy to perform side-by-side comparison of the series plot, and then you can see the hypothesis test, and then equation estimates, and then the model forecast developed under alternative assumption. Next, EViews also come with the function of import and export. For the import, EViews actually can read over 20 popular data format, which are the most common one is Excel, and then it also can read text, SPSS or SAS, and so on. Then EViews also come with the function of frequency conversion. So what the meaning of the frequency conversion means that if you import your data into the EViews, EViews actually can sort your data. Maybe you want from higher to lower, or maybe you want to change daily to monthly, and so on. Your observation also can be changed. For example, the screenshot over here, you can change, like if you want to see the average of your observation, or the summation, or the first of last of your observation. So the alteration of data are easier in EViews rather than you just manually go into Excel and edit or alter your data. So next is, these are the few tools that come with EViews. So as you can see in EViews, you can do basic statistical analysis. For example, if you want to see the mean, median, mode of the data, and then you can do the time series statistic and tools. You can also do panel and pool data statistic, and then you can do the automated RMA forecasting, and then you can also do a single equation estimation. Right. So, as I told you before, EViews are good in producing graph. So, in EViews, it supports a wide range of basic graph like line graph, bar graph, pie chart, and so on. So you can see over here are the screenshot of the graph that you can do. So what I like to highlight in the graphing, because we are not going to look detail in the function of the EViews for today. So what I like to highlight in the presentation quality output, that if you want to compare, for example, you have different column in your data. So you want to plot in one graphing, you can simply grouping your data in the EViews and plot it as a one graph. But you can also change the graph into multiple graph or different kind of like pie chart and bar chart. So it is easier to use EView for the graphing output. Okay. In EViews also come with the traditional command programming, which is in the command programming. In the, as you can see the screenshot over here at the top part, the white box over here, you can actually just put in some code. I would like to call it as code. Before this, if you want to do like graphing, you need to like click file or object to run the analysis, but you can just simply key in like LSY log as the estimation of your modeling, and then you click enter, and then it will come out with the equation, estimation equation. So it is it comes with two options in order to use the EViews. Okay. Next, EViews also come with the command explorer, which means that in the command explorer, in the help button over here, if you have any, maybe if you want to do forecasting, maybe after this I show you the forecasting of COVID-19. But if you want to do forecasting and then you do not know the step by step to do the forecasting, you can actually click help, and in the help button you can see the module of EViews. So in the module, it will come out with different topics. For example, like if you want to do graphing or statistical analysis or maybe forecasting, you can see on the PDF file itself. So other than that, EViews, so if you have any question regarding to EViews, you can actually go into their user community. Maybe some step that you did not sure how to do in the EViews, you can read in the comment section of the user community. So everything are in the EViews software itself. Next, this is the new function that come in the EViews 11. So if you have the latest EViews, you can integrate with Python script. So in the Python script, you actually can key in your Python to do the analysis, and then you also can see the output of your result in the Python script itself, so that you can copy and paste the code into the Python programming. Okay, next, this is also the new function that come in the EViews, which is a geographical map. So if you have like shapefile format, you can actually import the shapefile format into the EViews, and EViews can create a kind of like geographical maps in the EViews. So in the map itself, you can like differentiate with area, and then how many, for example, male and female in the area. You can see that, for example, the screenshot over here, the gradient of the population and so on in the geomaps. So these are the new function that come in the EViews. So next, we are going to look at the main event that we're going to discuss today, which is forecasting COVID-19 using EViews. So if you have any question during my next session after this, you can simply put in your question in the chat box, and then at the end of the session, I will try to answer back your question. Okay. So this part over here is the information. So if you have anything regarding to the license of the EViews, or you would like to purchase the EViews itself, you can contact our company, which is Statworks Group. It's okay, I will, after the end of the session, I will come back at this slide. Okay. So next, I will share to you the forecasting COVID-19 using EViews. So I need to show you the right. So I hope you can see my screen. Okay, so our topic today are COVID-19, which is we would like to do forecasting using EViews. Okay, so for the introduction, as you know, coronavirus disease or COVID-19 started in China in December 2019 and has spread all over the country. So the outbreak that started on 12 December 2019 continues to spread worldwide and result in fatality. So control of the pandemic is urgently essential, and science community have continued to do research treatment agent. So actually statistic forecasting model could aid to healthcare system in preventioning the COVID-19. So aim of the study actually the statistical prediction model could be meaningful in forecasting and controlling this global pandemic threat. So for this purpose, auto-regressive integrated moving average, or known as ARIMA model, was used to predict the cases of COVID-19 in Malaysia. So next I will explain to you our objective for this study. So there are three main objectives that I like to highlight in this study. So the first one is I like to study the pattern of COVID-19 cases in Malaysia. So the first objective over here is we would like to see either the pattern of the cases in Malaysia, is it seasonal pattern or not. Okay, next we're going to find the best model based on the box checking methodology, so that the model we can use to forecast the pattern of the COVID-19 cases in Malaysia. All right. So next, I'm going to explain to you the step-by-step how to do the forecasting in EViews. So the first basic one is you need to have a knowledge on the forecasting itself. You need to know the flow of doing the forecasting. So there are three major steps in doing forecasting. The first one is identify the time series, which is you need to have a time series data, and the data you need to have like daily or maybe monthly data to do the forecasting. Then the next one is you need to do the ARIMA modeling. So under the ARIMA modeling, you need to identify the stationarity of the time series. And then you need to determine the order of the single integer D, which means D means the how many different things you need to do for the time series in order to make it stationary. Okay. Next one is you will do the ARIMA modeling, and then you will perform a parameter estimation, and then do the diagnostic test and optimization. And that's for the ARIMA modeling step. And then the third step, when you already identify which ARIMA modeling are the best, and then you're going to focus on the selected ARIMA. So the first step is you need to find the best ARIMA modeling, and then you need to test the white noise, and then look at the goodness of it. All right. So that's the step. Okay, so the first one that I like to highlight is the data description. So as you know, in this topic, our data we only focus on in Malaysia. So these are the screenshot of Excel data that we get. So we have a daily data set. So the time range is from 25 January 2020 until 10 June 2020. So I believe these data are collected from my colleague. He key in every day for the total case. So as for now, we only have until 10 June. Okay, and then the data also consists 158 data. So as you can see over here, there are few different columns in the data. So we have date, which is our date in daily from January until June. And then we have total case, which means that total case are the cumulative count for each day. So for example, the first day is 3, and then the new case is 1, so total will be 4. So on the 26 will be 4 total cases. It will be total up of the number of cases. And then for the new case actually count on every day. So which means that on that day itself, how many cases that happen in Malaysia. And then for total active case, for active case, it's total out the active cases, which means not include the discharge case, and then it will cumulative count from day 1 until today. And then for the discharge case, discharge case means that patients that are free from COVID-19, and then for the total discharge case is the cumulative count from 25 until 10 June 2020. For the death case also count per day, and then for the total is the cumulative count for each death cases. Okay, so for the forecasting technique in the EViews, I decide to use new case as my wearable to forecast. This is because I believe people want to see the pattern, how many people will be in the future that have COVID-19. So I don't think that if you use total cases, the graph will be you can see the pattern on the total cases, as I believe that new cases are more logic for us to to do the analysis. So that's why I choose new cases to forecast. All right. So next is we're going to do the model identification. So for the model identification, actually you're going to have to investigate your initial data. So the initial data means your original data that you have from Excel. So what you need to do is you need to plot graph to see the pattern of the data. So at the initial stage, a simple data investigation was conducted to understand the basic pattern of the series and to identify any unusual observation or characteristic existing. So this is done by constructing a simple time plot. So as you can see from the graph over here, you can see a cursory observation indicate that the series is not stationary. So the series does not indicate any presence of seasonal effect because there is no specific pattern throughout the plotting. So what you can do in the EViews, I will share to you how you can do the plotting in the EViews. Okay. So as you can see over here, this is, I already import the data into the EViews. So you just double click the column that you want to do the initial data investigation. And then you click view and then click graph. And then you will click line and symbol. And then maybe because I already after the data itself. So basically what you need to do is you double tap over here, click view and then click graph, and then it will show you the graph exactly the same as I show you in the slideshow over here. Okay. So next what you need to do is in order to prove that your data is not stationary, because before this we only observe the graph, so we need to to find evidence that the graph the data is not stationary. Is the next step that you can do is do the parallelogram. So the ACF and the PACF were also plotted to collect more conclusive evidence on its stationary condition. So the ACF and the PACF for original data show the decaying pattern of the autocorrelation, while for the partial autocorrelation, such pattern was not noticeable. So we can see that few values of the partial autocorrelation exceed the significant limit. So we can conclude that the data are not stationary by looking at the parallelogram. So to do the parallelogram in the EViews, you just need to click view over here and then just click parallelogram. Then you can select the level, the parallelogram of first differencing or second differencing of the level itself. So next you will get the same graph as I show you in the PowerPoint. All right. So next is we're going to look at the unit root test. So this is also another test to know whether our data is stationary or not. So the significant value based on the ADF over here, we can see the P value is higher than 0.05. So since the autocorrelation have decay, partial autocorrelation has spiked, and the significant level is higher than P value, so we can conclude that the original data is not stationary. So since the data is not stationary, our next step is to perform the first differencing. So the next step, so for differencing is actually we want to make sure that our data are stationary before we go into the next model estimation. Okay, so to have this kind of table in the EViews, so you just need to click view and then click view on the selected column and then click unit root test. Then you can choose either standard unit root test or breakpoint or seasonal. Maybe if your data are seasonal, you can choose seasonal unit root test. As for now, just use standard unit root. And then you also can choose any kind of test type in order to compare the test statistics. For example, if you don't want to use ADF, you can choose DFGLS or maybe Phillips or so on. Then you just click OK, and then it will show you the same graphing as in the slide. Okay. So next is we going to do the first differencing. So for the performing the first differencing, so the first differencing was performed in order to render the original series stationary. So let the series in the first difference be the ZT over here. This is the first difference. So the formula are the YT minus YT minus 1, which means the Y means the column that we select, which is the new cases. So these are the formula. After you do the first differencing, you will have a new data set. So the data set will save into a new object. So what you need to do in the new object is actually same step as the first initial investigation, which is you need to see the pattern of your data. So based on the observation over here, you can see that the fixed level in this plot is 0. And then they have a constant mean and variance based on the time plot graph. So you can see that the high peak over here are almost the same same height level between both of the plotting. So by observing the graph, actually you can see that the graph are already stationary by doing the first differencing. So next step after you do the differencing is the same step as before. You need to look at the correlogram. So for the further evidence of the stationarity condition is obtained by plotting the ACF and the PACF. So the decaying pattern in both ACF and the PACF has disappeared, and that none of the autocorrelative values exceed the significant limit. So therefore, from the ACF and the PACF, we can conclude that the time series now is stationary. Alright. So to prove that, again, we can do the unit root test. So other than that, the significant value based on the ADF test statistic is less than the p-value, which is 0.05. So we can conclude that the series is stationary. But however, the series may not necessarily be perfectly stationary, because in most economic or business data series, such condition may not be easily achievable because of the unexplainable factor inherent in such data set. So after we do the analysis, the investigation of the data, and then we see the data, is it stationary or not. When we achieve the stationarity of the data, the next step is we need to do the model estimation and the validation. So the next stage in this analysis is to perform the model identification. So the process of identifying the suitable model to be fitted to the data series involves the analysis of the ACF and the PACF of the stationary series. So in order for you to select how many ARIMA you want to compare, actually you need to go back and see on the parallelogram of the ACF and the PACF. I believe that you already know that in ARIMA we have the PDQ of ARIMA. So D means the differencing, which means how many difference you do in order to make the data stationary. As for this data set, we only do first differencing and the data already stationary. So the D are 1. And then for the P and Q, you need to see the ACF and the PACF, which means that you need to see the spike. Let me go back to the ACF and PACF. Okay, so you can see the spike of the cutoff. You need to see the exit of the cutoff point. So the cutoff point is actually the dotted line in the ACF and the PACF. So for the P in the ARIMA, you need to see on the PACF, and then Q in the ARIMA, you need to look at the ACF. So to conclude, I already come out with 5 different ARIMA model, which is ARIMA 111, 112, 113, 211, and 212. Okay, so however, it needs to be reiterated that it is not easy to exactly specify the model class based on the evidence as provided by the ACF and the PACF, since we cannot summarily judge the effect of the magnitude of the spike on the model. Close scrutiny and the careful judgment of the location and size of the spike are essential to determine the number of lag required. So as a way out of this predicament, several possible models will be specified, estimated, and then perform the necessary validation or diagnostic test. So the model pick is the one that gives superior results. So these are based on the number of significant spikes. So these are the 5 models that have been identified and estimated. Okay, so next we're going to do the ARIMA 111. So in order to get this kind of graph in the EViews, let me share to you. So you need to click on quick and then click on the estimate equation, and over here you need to key in your equation. Over here in cases, and then C as for constant, and then AR, how many AR you decide to use, and then MA, for example this over here, ARIMA 111, and then you just click OK, and it will show you the table for the ARIMA 111. All right, so back to the slide. Okay. As you can see over here is the ARIMA 111. These tables are actually important for us in order to compare which model we would like to use for forecasting. Okay, next, the same step also you need to do for ARIMA 112. So these are the output when you do the ARIMA 112. And then you need to also do the same step for ARIMA 113, ARIMA 211, and then ARIMA 212, and ARIMA 212. Okay. So next are the model validation and the diagnostic checking. Okay, so for the model validation, actually the purpose of our model validation is to find the best model in order to do the forecasting. So we need to compare between the lowest value of the AIC, the IC, and then the MSE and the MAPE. So we can also do the hypothesis testing of the white noise. You can see the as H null as is the error are random or have white noise, and then H1, the error are not random, which is not white noise. So I already summarized all 5 ARIMA model, and so that we could see which one are the better modeling to be used. So as you can see, the highlighted one over here are the lowest value. So taking the value of the Q probability stat and comparing them against the P value, which is 0.05, we can accept that the null hypothesis that the error for each model are white noise. So hence the conclusion is that among the 5 well-specific models, so those based on the smallest AIC and BIC, RIMA 111 is the best. So over here, we decide to use ARIMA 111 as our model. So to verify our model, we can see the RMSE, the MAE in the model validation. So next, we're going to compare the best model with the average change model. So I already run the analysis to compare between which one have the lowest error, so that we can decide which model can be used. So in this project, I could identify that different kind of error, different best model. So for example, for MAPE, based on the observation, and MSE of ARIMA 111 model is lower than MSE of average change model, which is 4.7291. So furthermore, MAPE of average change model is lower than MAPE of ARIMA 111, which is 11.8367. Since the value of MAPE in average change model is lower, then the average change model is the best model. MSE is not a unique free measure and meaningless when different measurement units are used for different time series. Therefore, MSE cannot be used for comparing the model. So based on the observation, for MSE, based on the observation MSE of ARIMA 111, we can see that the model is lower than the MSE of the average change model, which is 34.7291. And then for the MAPE of average change model, it is lower than the MAPE of the ARIMA 111, which is 11.8367. Since the value of MSE in ARIMA 111 model is lower, then MSE in ARIMA 111 model is the best model. So next, I use the best model, which is over here, I decided to use the ARIMA 111 as the model. So as you can see, this is the historical data. I like to see the difference between the original data and the forecast. So over here, we can see that at the end of the graph, it has the same pattern, but slightly different from the original data. This is the in range output forecasting. But for the out of sample forecasting, this is the result that I get for new cases in Malaysia for COVID-19. As you can see, the pattern are different, and I believe that this happened because the machine learning actually learned the pattern from the previous historical data. So that's why we get like up and down pattern for the next upcoming months for the COVID-19 new cases. So for this forecasting, so to do forecasting in EViews, as you can see, for your original data, you only have like from January until June. But to do forecasting, you need to expand your date until, for example, over here until 31st December, so that the column can be so that the column can come out with the value of the forecasting using the ARIMA modeling. All right. So to conclude, I believe the ARIMA model forecast is a relatively advanced time series prediction method. It can be realistically describe the dynamic change rule. It can be used to perform statistical analysis and forecast for the time series under certain conditions. Specifically, the model is suitable for short-term prediction only. So large deviation occur when the forecasting time scale is long. So based on the EViews software, this will give time series modeling and forecasting with the ARIMA model. It should be noted that as for a specific time series that is subject to many factors, model prediction that relies solely on current values and historical data sometimes has a certain degree of deviation from the real situation. So for the recommendation, as I told you before, EViews for the ARIMA are only for the short-term prediction. So if you want to do the long-term, I think you need to study on different kind of machine learning to do forecasting. Maybe you can do the PERR modeling in order to do better forecasting value. Or maybe in the next project, I would like to suggest that you compare between EViews and another machine learning, which one can produce a better forecasting. So I believe overall for today, that's the only thing that I like to share for the COVID-19 forecasting using EViews. So overall, for short term, you can use EViews, but for long term, you can do, maybe you can go and study more advanced modeling or machine learning. So that's all from me for today. So right. So right now, I will have a look on the question in the chat box. So wait. Okay. So the first question is, okay. So the first question is, can we import the data from other software, example SPSS, into EViews to produce data output? Okay, so for other kind of data set, as I told you before, in this import and export, you can see that EViews can read and write over 20 popular data. So let me share to you which data that it can be read. Okay. Click file, open, click foreign data, and then you can see which kind of data over here. You can read EViews, SPSS, yes, can be read also, and then can come out with output as well. You can do analysis in the SPSS data. Next, what's different between new cases and total active cases? Okay, for that one, okay, wait, huh? Okay, so for the active cases, actually, active cases did not include total people had that discharged on that day. So active cases only only for people that have the disease, the virus, not include the discharge and the death. Okay. Okay. So next question is, can you explain briefly to simplify what those parameters mean for, and what is unit root and how it is different from others? Okay, for this part, actually, I need to have more time to explain because there's a lot of parameters that I need to explain. But what can I say that if you Okay, for now we are focusing on doing forecasting. So what you need to understand is you need to know either the data is stationary or not. So in order to do that, you need to do the unit root test and then the parallelogram to see whether the data is stationary or not. So that's what the function of unit root test and then parallelogram. Maybe parallelogram mean that can be used for identify stationarity of data and also to build the ARIMA modeling. While unit root test only provide evidence that the p-value, the hypothesis testing for the p-value mean that the data is stationary or not. Okay, so next the question is, could you provide useful sources for us to learn more about this analysis and parameter? Okay, for this one, actually, you can have a look on the PDF in the EViews itself. So let me share to you how you can see the PDF. You go to the EViews if you already have EViews. Go to the EViews and then click on the help and then go into the PDF and download the user guide 1 and 2. Over here, they will cover up different kind of topic. I think they cover the parameter as well. So if they're not covering the parameter, you can actually Google each of the function itself. Okay, next. Can you please explain how to select PQ from ACF and PACF? So for the ACF, for the ARIMA modeling, for PQ and D, so D are the different things. So for the P, actually, you need to look at the PACF spike. So for example, over here, let me get back to my slide. Wait. Okay. Okay, so as I told you before, P, you need to look at the PACF spike. So what you need to do is you need to look at the spike that exceed the cutoff point. So as you can see over here, the cutoff point have two. You see, like other than these two, the spike not exceed than the cutoff. So that's why you can do the P from 1 until 2 because they have two spikes that exceed the cutoff. Same goes as the Q, but Q you need to look at the autocorrelation spike. See which one spike exceed the cutoff. So as for Q as well, have to. So, all right. So next question. Just this one. Okay, so next question is, does this model that used to predict or forecast future trend take into consideration of other variable factor that could affect the forecast of future trend? Can EViews take consideration of those factors? So for the modeling estimation, you can actually put your modeling. For example, if you want to consider other variable as a factor as well, you can put in the estimation. For example, before this, I put new cases only, but you can put like new cases with total death and then put C as constant and then put ER1 and then MA1. So you will consider another future, another factor as well. As for now, I only use one factor because I believe only one factor that makes sense to do the plotting. Okay, so next, I think I answered all of the questions. So overall, if you have any question regarding to EViews itself, you can you can email us in this email, or if you have any question regarding to step in doing forecasting, or you're not sure, you do not understand certain function, you can personally email me at my email. I will share in the chat box. Okay. So you can email anything regarding to the EViews to my personal email. But if you have question on the license and everything, you can email me to this email, sales email. So I think that's all for today. If you like to understand more about EViews, actually I do training, EViews training for this software. So you can contact the sale, I believe, for if you want to join the training session. On the training session, actually I will cover everything from a basic EViews and advanced EViews. So in which that in basic EViews, I will cover how to do EViews work file basic, which is creating work file and then work file window. And then I will also cover how you can handle your data, which is how you can investigate your data statistically. And then I also will teach you how to do graphing analysis, which is statistical graphing and then multiple graph display. And then in advanced, in basic also, I will teach you how to estimate regression model and do forecasting. So for the advanced, I will teach you how to do panel data, how to manage panel data, and how to do programming using the EViews. And then I also will teach you how to use the new feature of EViews, which is pattern integration and the geographical map. So if you're interested, you can email to us if you want to join the training session. So I think that's all for today. If there is no question, I think we can stop here. So thank you so much for attending my webinar session today. So I hope that my study or my project can help you to get idea what you can do to help to prevent the COVID-19 in the future. So thank you so much and have a nice day.